I expected 17 to 5 or mistake. Y'all see trig, you just freeze. All right. And 17 is a little strange. It's a little different. Okay. All right. So I've got y equals x minus 2 cosine x. Is that right? Is that the right one on 17? Page are we on?
211.
211, I'm sorry. All right, so I've got g of t is t times the square root of 4 minus t. All right? All right, and then it says, by the way, t is less than 3. Now, the only reason it's telling you t is less than 3 is because what if t was 5? What would 4 minus 5 give you under this root? A negative. Is everybody with me? So they're trying to make sure that they're just making sure you realize, they don't want, you're not gonna have a negative under here. Now, here's the first thing. What do roots keep getting changed to?
Powers.
Powers. All right, so that's the first thing I would do. So that's gonna be 4 minus t to what power? 1/2? Now, what does that parenthesis mean for me to do with these two things? What's understood to be between this t and this parenthesis?
Multiplication.
All right, it's multiplication. So what rule am I about to have to use when I do the derivative? Isn't that a product? So I've got to use what? Product rule. So is the product rule the derivative of the first times the derivative of the second? No, I wish it was, but that's not it. Okay, what's my product rule say? First, I just copy the first one down, correct? And then I do the derivative of the second one. So this is something to a power. So what happens to the power? Comes down. My expression stays the same. What's my power do? Doesn't it go down 1? So what's 1/2 minus 1 gonna get me?
-1/2.
-1/2. Now, if you stop there, you've not finished. What's the next thing you have to do after you take the power? Derivative of what? The inside. So what's the derivative of that inside gonna be? 0 what? Minus what? 1. So it's gonna be a -1. So does everybody understand that that bracket is the derivative of that thing? All right, plus or minus on product rule?
Plus.
Plus. Then I copy down the second one. So I've got 4 minus t to the 1/2. Now I need the derivative of the first. All right, so what's the derivative of t? It's just 1. All right, so the first thing I'm gonna do is clean it up a little bit. So I can pull this negative and this 1/2 out front. So I've got a -1/2, and then I've got a t, and then I've got a 4 minus t to the -1/2, plus, and then I've got a 4 minus t to the +1/2. All right, everybody okay? Now, let me go over here and ask you a question. What if you had like an x squared plus an x to the 5th, and I told you to factor something out? So this has nothing to do with that, except I'm gonna remind you about some algebra, okay? Hannah, what would I factor out? The x to the 2 or the x to the 5? How did you know to do the 2? Because you picked which one? The smaller one. All right, look right here. Do you see that you got a 4 minus t in both? I've got a power of a -1/2 and a power of a +1/2. Which power is smaller? -1/2, what's smaller? -1/2 or +1/2? -1/2. So I'm going to factor out 4 minus t to the -1/2. Just like over here, I would factor out the smaller power x squared. Okay? Because remember, after you take the derivative, you clean it up, your derivative's got to be fully factored. Now, when you pull 4 minus t to the -1/2 out of this first term, what does that just leave us? A -1/2 in the t. Everybody okay? Plus, now, here's the part that freaks people out. What do you, when you pull, in other words, I'm gonna have 4 minus t to some power right there. Now, here's what I do. What do you do when you're multiplying? What do you do with the powers when you're multiplying? You add them. So do we understand that -1/2 plus this question mark has to equal a what? +1/2. So what do I add to a -1/2 to get a +1/2? 1. So that's how I know that power is a 1. All right, so let's make sure we're clear. Let's double check it. That'd be 4 minus t to the -1/2 and the -1/2 t. -1/2 t, 4 minus t to the -1/2. Yep. And if I multiply this by this, because the bases match, I would add those exponents, and the -1/2 plus 1 is indeed a positive what? 1/2. Now I can do something with this thing in the front. So I've got a 4 minus t to a -1/2. I've got a -1/2 t. Now that's a power of 1, right? So that's just plus a 4 minus a t. In other words, that power is not really doing me any good. So I've got a 4 minus a t to the -1/2. Now, what's a -1/2 t minus another t? It's a -3/2 t, isn't it? When you got a -1/2 t minus another whole t, don't you have a -3/2 t? So I'm going to have a 4 minus a 3/2 t. Now, do we like negative exponents? We don't usually, do we? So how can I make this exponent positive? Where can I move it? To the bottom. So I've got a 4 minus 3/2 t on the top, and I've got a 4 minus t to the 1/2 on the bottom. Now, you don't necessarily need that parenthesis on the top, but you know, I put it there just in case it was clear. So that is my derivative fully factored. Everybody okay? Now, let's make a split point table out of it. Do we see that we've got 2 factors? I've got a factor on the top and a what? Factor on the bottom. Okay. So one of my factors is 4 minus 3t. All right, remember what we got to do? We got to find the split point for that. So the split point is when that factor equals 0. All right. So if I add 3t to both sides and then divide by 3, what does t come out to be? 4 what? Like solve that for t. What do you get? T is what? Solve this 6th grade problem, please.
4/3.
Thank you. So somewhere on this number line is 4/3. Okay. So the split point is where that factor equals 0, and you just solve it. Okay.
Where did we get that from, the 4 minus 2?
Oh, I'm sorry. What is it? Should be, thank you, Helen. It should be 4 minus what? 3/2t. That makes a difference. All right. So 4 minus 3/2t is 0. Says 4 is 3. 4 minus, so 3/2 t. Now, how do I get rid of that 3/2? What have I got to multiply both sides by? 2/3. All right, so if I multiply this side by 2/3, then I've got to multiply this side by 2/3. So I get 6/6, which is 1. So what does t come out to be? Not 4/3, but what? 8/3. All right. Thank you. All right. Now, what do? We pick a number smaller and the number bigger and we plug in there, right? What's an easy number that's smaller than 8/3? I'd pick 0 if it were me. Because what's anything times 0 gonna be? 0, and 4 minus that's gonna be what kind of number? Positive. Okay? Now, isn't 8/3 like 2 2/3? Right? So give me a number bigger than 8/3. All right, 4. All right, so what's 3 times 4 gonna give me? 12, and what's 12 divided by 2? And 4 minus 6 will be what kind of number? It'd be negative, wouldn't it? Okay. Now, my other factor is what? 4 minus t to the what? 1/2. Now, here's what I've told you all along. You're welcome to leave things in fractional powers, but I'm about to plug numbers in and I don't think well in fractional powers. So what's another way of writing 4 minus t to the 1/2? What's that as a root? That's the square root of 4 minus t. If I'm gonna plug numbers in, it's easier for me to plug them into a root. All right, what's the split point for that? When does that equal 0? Well, what am I going to do there? How do I get rid of that root? How do you get rid of the square root? Again, this is 6th grade arithmetic. What do we do to get rid of a square root? We square. So if I square this side, I've got to square that side. So what's going to happen when I square this square root? Don't they go away? So that leaves me 4 minus t equals what? 0. So what is t equal? What number?
4.
4. Now, is 4 to the left or to the right of this 8/3?
Right.
To the right. All right, what's an easy number that's smaller than 4 that I can plug in to this root? 0. Okay, what's 4 minus 0? 4, and the square root of 4 is 2. Is that positive or negative? Positive. Now, let me show you something that's a little weird right here. If you try to pick a number bigger than 4, what's going to happen to this?
It'll be a negative number.
It'll be a negative number, which is undefined, right? That's why they told us to let t be smaller than what? 3. So really, they're not going all the way up to 4. They're only going up to what? They're stopping this thing at 3. So they don't care what happens past 3. Okay? So all my factors are on my table. So what does it mean when you've got one on top of the other? Aren't you dividing them? So what's a positive divided by a positive going to get me? Isn't that a positive? And what's a negative divided by a positive going to get me? A negative. And they don't want anything bigger than 3. They want t to be smaller than 3. So does it make sense then that this thing, except here, would they want me to do the table or just find the critical values on this one?
Critical numbers.
Oh, well then we did way too much. The critical numbers are just where this thing equals what? 0?
0.
All right, so let's go back then. But that's how we would do it. So you understand it would increase here and what? Decrease there. All right, so let's go back though. What they were wanting was just critical values, which was way easier. So all we have to do right here is decide when is this derivative either 0 or what? Undefined. All right. So when is it equal to 0 and when is it undefined? All right. When is a fraction equal to 0?
And then raise zero.
with the numerator 0. So all I really got to worry about is 4 minus 3 has t is 0. And that's where we got 8 a minute ago. Okay? So we got 3 has t was 4. We multiplied both sides by our 2/3. And t came out to be 8/3. Now, isn't that number 2 2/3, so isn't it smaller than 3? So it's a critical value. Now look at this one. When is a fraction undefined when what is 0? The denominator, right? So when is 4 minus t to the 1/2 equal to 0? Well, that's the one we did a minute ago. We changed to a root. And we squared both sides. So we got 4 minus t was 0, and we got t was 4. Now, when you turn to the back of the book, this is the only one that's going to be listed. Why don't they list this one for a critical value? Because they said in this problem they want t to be what? Smaller than 3. So this one is thrown out because of their initial condition. But if that had been missing, then we would have 2 critical values. So for critical values, I can just find out where the derivative equals 0 and where the derivative is undefined. I don't have to make the split point table. Okay? Is there another one that you want to look at on your homework? Look on page 227, because what we're going to do today is the same thing, basically. Kendall?
Number 33.
Number 33, is that on page 227? Okay, so 33. All right, so we've got x to the 1/3 plus 1. Okay. Get this right. All right. So 33 says f of x equals x to the 1/3 plus 1. And again, I doubt that you know what that graph looks like without your graphers. Okay. So the directions told you to find the critical numbers and find where it increases and decreases, all right? So let's go do the derivative. All right, what's the derivative of x to the 1/3? I bring the 1/3 down, I keep that x. What's my power going to go to? What's 1/3 minus 1?
Negative 2/3.
Good, negative 2/3. And then plus what? 0, isn't it? Now again, we don't usually like negative exponents. So what can I do with this x to the negative 2/3? I can bring it where?
Bottom.
To the bottom. That's going to make it x to the positive what? 2/3. Now again, I'm about to make a split point table. Okay? And I don't do well plugging in numbers with fractional power, so let's change it to a root to make our life a little easier. Would that be cube root or square root when your power is a 2/3? Which one's the index number, the denominator or the numerator? The denominator, so that's going to be the cube root of x what? Squared. Now, when you make your split point table, it's supposed to be fully factored, but can I do any factoring there? I can't. Now, part of it depends on how many factors you see. Some people see 3, some people see 2. I'm going to treat it kind of like it's 3, just to be kind of extreme. I've got a factor of 1, a factor of 3, and a factor of what? This cube root. Some people just see the 1/3. Okay? Now, does 1 have a split point? Is 1 ever going to equal 0? No. So that means either that's positive all the way across or negative all the way across. What is it? Positive. Positive 1's always positive. Same thing with this 3. 3 is not ever going to equal 0 in this number system. So there's no split point, and a positive 3 is always what? Positive. Now, another factor that I've got is the cube root of x squared. Now, does the cube root of x squared ever equal 0?
Yes.
Yeah, when x is what?
Zero.
0. Now, you might just see that. If you don't, do you understand you can cube both sides? That would give you x squared is 0, and then take the square root of both sides. Either way, you're going to get 0 for the split point. All right, give me a number smaller than 0.
-1.
-1, all right? What's a -1 squared, and then you take the cube root of it? What's a -1 squared?
1.
1, and the cube root of 1 is 1, and that is
Positive.
positive. All right. What if I put in a positive 1? A positive 1 squared, and I do the cube root. What's a positive 1 squared? It's also what?
1.
1, and the cube root of 1 is also what?
1.
1. Now I'm supposed to multiply these two and then divide it by that one. But what happens when the powers are positive, all positive? What happens when you multiply and divide positive numbers? They just stay what? Positive. So what's true about this thing about increasing? It's always increasing. It's going up all the time. So you could write down always increasing, or you could say that it increases from negative infinity to negative infinity, however you want to phrase it. All right, if it's going up right here, are you going to have a max or min? So it doesn't have any maximums or minimums. It's always increasing. The derivative is undefined at 0, so 0 is a critical value, but nothing's happening right there. All right, it's a potential, but it doesn't pan out. Okay. Is there another one you want to look at?
Number 15.
Which one, middle? 15? All right, so 15, I've got sine x minus 1. Okay. All right. All right. And again, we make sure I understand the directions. They still want me just to find basically where this function's increasing or decreasing. All right, and luckily they tell me that my x is between 0 and 2 pi. Okay, let's go do the derivative. All right, what's the derivative of sine of an angle? Cosine of the same angle. All right, but what's the derivative of my angle? Just what? Just 1, right? Derivative of a single variable is 1, and then minus, what's the derivative of that constant going to be? 0. So my derivative is just cosine x. Now, there's no way to factor that, and I've only got one term. So how many things are going to be on my split point table? Just what? Just 1. I've got the cosine of x. Now on this number line, it doesn't have arrows on the end because I'm starting at 0 and I'm stopping at what? 2 pi. So it's, now why did I draw open holes there instead of closed holes? When would I draw closed holes if it said less than or what? Equal to. Okay, so I've got open holes. Now, remember what a split point is. A split point is where that factor equals 0. So my factor is cosine x. So I need to know, when does cosine x equal 0?
90 degrees.
think about your unit circle. Remember what your unit circle is. It's a circle whose center is at the origin and the radius is 1. So what's that coordinate right there? 1 what?
1, 0.
1, 0. That one's gonna be
0, 1.
0, 1. And that's gonna be -1, 0, and what?
0, -1.
Everybody okay on that unit circle? Now, is cosine your x coordinate or your y coordinate?
X.
X. So where on that circle is x 0? So Sam said one place is right here.
90.
So that's pi over what? 2. So I don't want radians. You can put 90 degrees in parentheses if you need to. Is that the only place though?
No.
Where else?
270.
270, which is what? 3 pi over 2. Now, so sometimes, especially trig, may have more than one split point. Okay, so I'm going to have to pick a number here, and here, and here. Now, will you have your graph or is it your test? What's the answer? No.
No.
But will you have a scientific calculator? Now, I don't care what the answer is. All that I care is that the answer is either positive or what? Or negative. So here's what you could do. Now, you could plug in any angle between 0 degrees and what? And 90 degrees, correct?
Mhm.
But because this is just one factor, think about it. If you're between 0 and 90, would you be in quadrant 1?
Yes.
What's the cosine of any angle between 0 and 90 degrees? What's the cosine of any angle in quadrant 1?
Positive.
Isn't it positive? Because cosine's your x value, isn't it? All right, what about between 90 and 270? All right, here's 90, and here all the way to here's 270. So if cosine's your x coordinate, what's your x coordinate here and here? Positive or negative? Wouldn't you have to go left to do a point? Negative. Between 270 and 360, it's going to be positive again. But if you get confused by that, you've got a scientific calculator. So you can literally just type in, what's the cosine of 12 degrees? It's going to give you some decimal, but all you care that on the calculator, the decimal is a positive decimal. You can pick any degree, 100, 203, it doesn't matter, any angle between 90 and 270 in your scientific calculator and type in the cosine of that, and you'll get a negative in a decimal. But all you care is that it's what? Negative. All right, so where does this function increase? Where would it increase? What would I write down on my test? Where's the final answer positive? Isn't it positive here and here? So what would I write down? 0 to what? Pi over 2, or, union is your symbol for or, what? 3 pi over 2 to what? 2 pi. Where does your function decrease? Between what? Pi over 2 and what? 3 pi over 2. Now, I want you to think about it. Use your hands if you need to. Isn't it going up here? If it's going up and it turns and goes down, what are you going to have at the turn? A max or a min?
Maximum.
A max. So I've got a relative max at the point pi over 2 something. I'll worry about the something in a minute. Okay? Now, it's decreasing here. So if it's going down and it turns and goes up, what are you going to have at this turn? A minimum. So I've got a relative minimum at 3 pi over 2 comma something. Now, how do I get the y coordinates for these points? Where do I plug it back into? The derivative or the original? The original. So let's go plug in pi over 2 on the original. Okay. So when I plug pi over 2 in, I've got the sine of pi over 2 minus 1. Now, that's the sine of 90 degrees, correct? All right, what's the sine of 90 degrees? Isn't that your y coordinate? What is it? What's the sine of 90 degrees? 1. What's 1 minus 1? 0. Here's my y coordinate. Same thing. What if I plugged in instead 3 pi over 2? Then I've got the sine of 3 pi over 2 minus 1. Okay? 3 pi over 2 is 270, correct? So what's the sine right here? It's not 1, it's what? So what's a negative 1 minus 1 more going to give me? So that's where my function increases and decreasing. That's its relative max and its relative min. And that will be helpful when I go to graph it. Okay? So part of this is mostly algebra skills. So you got to be real careful when you take the derivative. And you got to be really careful when you factor. And you've been doing the same thing before next week. So you'll get a lot of practice. All right, so let me show you what we're going to do today. All right, here's what we're going to do today. Remember what your goal is. The reason we're doing all of this is because eventually we're going to put all this together and make some graph. Okay? So do we understand that if you had a graph and you knew that you had a point here and you had a point here, even if you knew that the function was increasing, how are you going to connect those dots? It might be that the graph curves up. That's going up, isn't it? That's increasing. Or it might be that the points are connected like this. That's still going up, but they're cupped differently. In other words, this one, if you kept going, do you see it'd be like a cup sitting up that would hold coffee? Do you see on this pink one, if it kept going, would that be like a cup sitting down? So they would say the blue one is cupping up, and they would say that the pink one is cupping what? Down. Now the math word for cupping is called concave. So this blue one's concaving up, and this pink one is concaving down. So I'm going to need to know how the function's cupping so I know how to draw it. Now, what if it was just straight? If it was just straight, does it cup at all? No, it'd have no concavity. Now, let me show you something. So this, your book's going to say concaves up, or it might say upward, either way. And this, they would say concaves down, or downward. So tonight, instead of just asking you where it increases and decreases, they're going to ask you that. Then they're going to add, how's it cupping? Where is it cupping up? And where is it cupping down? Now, do we agree, just like we were doing before on graphs, remember when we were drawing those tangents to decide where the function was increasing or decreasing? All right, I'm just going to make some numbers up. Since these tangents are going down when you look left to right, will the slopes be positive or negative?
Negative.
They'd be negative. Maybe this one's a -2. Maybe this slope is a -1/2. If it's horizontal, it's 0. maybe this slope is like a 2/3. Maybe if you get way up here, it's really steep, and that slope is something like a 4. Do you see the slopes go from -2 to -1 to 0 to 2 to 3? Are these slopes increasing or decreasing? What are these slopes doing? -2, -1/2, 0, 2/3, and 4. Are those slopes getting bigger or smaller?
Bigger.
They're getting bigger, aren't they? So the slopes of the tangent lines are increasing. Now, what are slopes of the tangent lines the same thing as? The derivative. Now, how did I find when the original increased or decreased? What did I do to the original? What did I use on the original to decide whether it was increasing or decreasing? I took the what? What have we been doing the whole time over there? Taking the what? We've been taking the derivative, hadn't we? Well, now I'm going to have to take the derivative, thanks, of the derivative. So what do you call the derivative of the derivative? That's the what? Is that the second derivative? When was the original increasing? When the derivative was positive or negative? When it was positive, right? So when the second derivative is positive, concaves up. Where the second derivative is negative, it concaves down. All right, so let's make sure we're clear about something. If I tell you to find where a function increases or decreases, which derivative does that? First or second?
First.
First. Okay. So this one you use the first derivative. Right? So do we understand that the first derivative gives us where the function increases and where it decreases? And what else do we get from that first derivative? Relative what? Minimums and what? Maximums. I'm just going to call that relative extrema. That's what your homework was for today. So if the directions tell you to find where this function increases or decreases, or it says find the maximums and minimums on the graph, you make a split point table for the first derivative. If it says find where the function concaves up or down, that's when you're going to have to use the second derivative. And you're going to do exactly the same thing. You're going to make a split point table. And this is going to give you where the function concaves up or down. It's also going to give you something called an inflection point. Inflection points are just where the cupping changes, like from down to up or up to down. All right, so we're going to go do one from start to finish. here's our function. X squared plus 1 over x squared minus 4. Got to move backwards. Now, here's what I want to know on this graph. I want to know where that function increases. I want to know where that function decreases. I want to know a relative minimum, if there are any. And I want to know a relative maximum, if there are any. I want to know where that function cups or concaves up. I want to know where that function cups or concaves down. And I want to know any inflection points. You have to do all that plus more on your next test. Okay? So let's go do it. Now, what's going to tell me increasing, decreasing, maxes, and mins? Which derivative? First. So you help me get this first derivative. Now, aren't I going to have to use the quotient rule? So where do I start, top or bottom? Bottom. So I copy down the bottom. X squared minus 4. All right, what's the derivative of that numerator up there?
2x.
2x. Is it plus or minus on quotient? Minus. Then I copy down the top, so I've got x squared plus 1. And I do the derivative of that denominator. What's that going to be? Isn't that also 2x? And then the whole thing is over the bottom what? Square. So I've got to know my derivative rules. All right, is everybody with me so far? We good? Now, don't I have to fully factor this thing? Well, then before you start multiplying stuff up, look and see, is there in that numerator, is there anything that's in this term and this term that I can go ahead and factor out? What? 2x. All right, then let's do that. If I factor a 2x out of this one, what's it going to leave? X squared what? Minus 4. And then minus, and if I factor the 2x out of this second term, isn't that going to leave me an x squared plus 1? Everybody okay? And all that's over x squared minus 4 squared. So I've got a 2x on the top. Now I can multiply this out. That first parenthesis isn't doing me any good. So I can drop it. But I've got to distribute that minus. So that's going to be a minus x squared and a what? Minus 1. Is that correct? And all that's over x squared minus 4 squared. What goes out up here? Was x squared. That leaves me a negative 4 minus 1 more. What's that going to leave me? Negative 5. Now, I want you to notice something. Is this thing fully factored? Well, see, it's not, because doesn't x squared minus 4 factor? So I've got a 2x. I've got a negative 5. What does x squared minus 4 factor into? X what? Isn't that perfect squares? So it's x minus what? 2 and x plus 2. But that whole thing is what? Squared. So I've got a 2x. I've got a negative 5. That squared goes with both of these. So I've got x minus 2 squared, and I've got x plus 2 squared. Now it's fully factored. So this is what I'm going to make the split point table for. Now, when I look at that, I see 4 factors. Do you see 4 factors? So I've got to put all 4 factors on a split point table. All right, so help me. One factor is going to be a 2x, isn't it? Okay. What's the split point for 2x? When does 2x equal 0? When x is what?
-2.
When does 2x equal 0? When x is what? 0. So somewhere on this number line is a 0. All right, give me a number smaller than 0.
-1.
-1. What's 2 times a -1 going to be? Positive or negative? It's going to be negative. If I pick a number bigger, like 1 or 2, and I multiply it by 2, what's going to happen when you multiply a positive number by 2? It's going to stay what? Positive. So does everybody understand why those positives and negatives are the way that they are on this factor? All right. Another factor that I have is a -5. Now, does a -5 ever equal 0? So that means this thing's either negative all the way across or positive. What's a -5? Always what? What kind of number is it?
Negative.
It's negative. Now, I've got another factor. I've got x minus 2 what? Squared. All right. What's the split point for that? When is that thing going to equal 0? When does x minus 2 squared equal 0? When x is 2. Now, where is 2 in relation to 0? The left or the right?
Right side.
Somewhere on the right side. So all I'm doing is looking at this pink factor and that pink number. What's an easy number to plug in that's smaller than 2? 1. All right, what's 1 minus 2?
-1.
But when you square a -1, what's that going to be? It's
Positive.
going to be positive. What if you plug a number in like 5? 5 minus 2 is 3. What happens when you square 3? It's also going to be what?
Positive.
Positive. Now think about why that really, you should have known that before you started plugging numbers in. Or when you square something, is it ever going to be negative? No. It's either going to be 0 or it's going to be what? Positive. All right. Then I've got an x plus 2 squared. Now, when is an x plus 2 squared going to be 0?
-2.
When x is a -2. So a -2 is to the left. So now looking at this green factor and that green number. But what happens because I'm squaring it? What's that going to be all the way across again? Positive. Now, I'm supposed to multiply these and multiply those and then divide. Okay? Positive times a positive is a positive. What's a negative times a negative? Isn't that a positive? So what happens when I take a positive and divide by a positive? What's this final sign going to be right here? Positive. Same thing right here. That final sign is going to be what?
Positive.
Positive. What's my final sign going to be here and here?
Negative.
Negative. So let's go fill in. Where does this function increase? Where the final sign is positive or negative? Where the final sign is what? Positive. So from negative infinity to what? -2, and then from -2 to what? 0. And I would write it like that. Negative infinity to -2, and then -2 to 0, union. Because from test 1, I can already tell it's going to vertical asymptote somewhere. Like, where does this thing decrease? From 0 to what? To 2, union 2 to what? Infinity. Well, let's see if it's got any minimums or maximums. If it's coming up and it keeps coming up, I don't have anything there, right? But if it's coming up and it turns and goes down, what are you going to have at this turn? Maximum. So it's got a relative maximum at 0, something. All right, once again, if it's coming down and it keeps coming down, nothing happens right there, correct? So what does that mean about minimums? Apparently I don't have any. Now, how do I get this y coordinate? Where do I plug that 0 into? The original. All right, so 0 squared plus 1, 0 squared minus 4. What does that give me?
-1/4.
Negative 1/4. So I got the increasing, decreasing minimums and maximums from the first derivative. So now we're gonna go get the concaving up and down and inflection points from the second derivative. Now, this is my advice. I would not use this factored form to do the derivative. Because if I do the derivative of this, I don't want to use the product rule in the middle of a what? Quotient rule. I'd probably go back to this one. And I would even fix the top. What can I turn that top into that would be easier, right? So I wouldn't have to use the product rule.
-10x.
There we go. So sometimes when you're about to do the second derivative, go back to what I call a friendly form of your first derivative. So my first derivative is a negative 10x over x squared minus 4 squared. So does everybody see where I got that from? Is everybody okay? Now, let's go do the derivative of that. So the derivative of the first derivative is indeed the second derivative. I'm going to have to use the quotient rule again. So again, I start on the bottom. So x squared minus 4 squared, I copy it down. What's the derivative of a negative 10x? Negative 10. All right, plus or minus on quotient rule? Minus. And I copy the top down, negative 10x. Now I've got to do the derivative of the bottom. So I have to use power rule. So that power comes down. My expression stays the same. That power goes down by 1. But I've got to do the derivative of the inside. So what's the derivative of that inside?
2x.
2x. So make sure you do the whole derivative. And all that is over my denominator squared. Now, again, don't just start multiplying stuff up. Look at that numerator. Is there anything that this one and this long one over here have in common that I could factor out? They have an x squared minus 4. Anything else?
2.
They both have a what? Don't they both have like a 10? Everybody with me? Matter of fact, I can even factor out, so the 10, I can factor out a what? A negative 10 if I wanted to. All right, so you help me then. On this first term, I factored out the negative 10, and I factored out one of these x squared minus 4s. So what's that going to leave me? What have I got to multiply this by to get that?
X squared minus 4.
Another x squared minus 4. Very good. Because I need 2 of them, and one and another one is leaving my 2. It says minus, so I'm going to write down minus. Now, there's the negative 10 that I pulled out, right? And there's the x squared minus 4 that I pulled out. So what's this going to leave me over here?
X.
I will have that x. What else am I going to have? This what?
2.
2. And what else am I going to have over here?
2x.
2x. And all that's over x squared minus 4. What happens when you have a power to a power? You multiply. I mean, 2 times 2 is 4. All right. So I've got a negative 10 I've got an x squared minus 4. Now let's see what this does. That first parenthesis isn't doing me any good, so I'm gonna drop it off. So x squared minus 4 minus, what's that end up being? 4x what? Squared. Now let me ask you, so I've got x squared minus 4 to the 4th. So I've got a negative 10. I've got an x squared minus 4. Okay, what's that? What's an x squared minus a 4x squared gonna give me?
3.
What kind of 3x squared?
Negative 3 squared.
So I've got a negative 3x squared and then minus 4. Now let me ask you something. Do you see I've got 4 of these? Why am I writing it like this? What am I trying to help you see when I write it like that?
You can factor out.
I can get rid of one of the x squared minus 4s on the bottom and on the what? On the top. I can get rid of this one and this one. So that's going to leave me a negative 10 and the negative 3x squared minus 4. Now, again, I've got an x squared minus 4 cubed. But is x squared minus 4 factored fully?
No.
It'll factor into x minus 2 times what? X plus 2. All that is cubed. So I've got a negative 10. I've got a negative 3x squared minus 4. And I've got an x minus 2 cubed and an x plus 2 cubed. Is everybody okay? Now that thing is fully factored. Let me tell you what, I'm not going to do it, but I'll probably, if it were me, I'd probably factor a negative 1 out here, and then a negative times a negative is a positive and get rid of the negatives. But I'm going to do it this way for right now. So again, I've got 4 factors to put on a split point table. Negative 10. Okay? Does negative 10 have a split point? Is it ever going to equal 0? No. Is it negative all the time or positive all the time? What's a negative 10? It's always what? Negative. All right, I've got another factor. Negative 3x squared minus 4. Now watch this, negative 3x squared minus 4. When does that equal 0? Well, that would equal 0 when the negative 3x squared equal to what?
4.
Would be 4. How would you get rid of that negative 3? What would you do both sides? Divide. So look what we're saying. When is x squared ever going to be a negative 4/3? When is x squared going to be a negative anything? Does this have an answer? Then that means that this factor is never going to equal 0. So just like this one, that means it's either positive all the way across or it's what?
Negative.
Negative all the way across. How do I decide whether it's positive all the way across or negative all the way across? Stick a number in and see. What's the easiest number to stick in for x that you can think of?
0.
0, okay. 0 squared 0, negative 3 times that 0. What's 0 minus 4 going to give me? So this thing is negative all the time. All right, x minus 2 cubed. What's the split point for x minus 2 cubed? When is that thing going to equal 0? When x is what number? 2. So somewhere in this number line, there's a 2. If I put a number in like smaller than 2, like 0, 0 minus 2 is a negative 2. What happens when you cube a negative? It's negative. If I put a number in bigger like 3, 3 minus 2 is 1, and 1 cubed is 1. So it's positive. Okay. And I've got one more factor. I've got x plus 2 cubed. All right, when is that thing going to equal 0?
Negative.
When x is a negative 2. And the negative 2 is to the left of a positive 2. So again, I'm just looking at this pink number and this pink factor. What's a number to the left or smaller than a negative 2? A negative what? 3. Well, a negative 3 plus 2 would be a negative 1. What happens when you cube a negative 1? It's negative 1. If I put a number in bigger like 0, 0 plus 2 is 2, and 2 cubed is 8, and that's positive. So do you understand I'm doing the same process I was doing for first derivative? I fully factor it and I make a split point table. And then I find out where the final thing is positive or negative. All right? Negative times a negative times a negative times a negative. What's the final answer going to be down here? What kind of number?
Positive.
What happens when you have an odd number of negatives and you're multiplying or dividing? What's a negative times a negative? But a positive times a negative would be a what? So the final answer is negative. And when you've got an even number of negatives, you see why it's going to be a positive. So where does this function concave up? Before negative 2, so negative infinity to negative 2, union 2 to what? Infinity. And where does this function concave down? It concaves down between negative 2 and what? 2. So go fill that in your table over here, and I'll flip the camera in a second. So it concaves up then, what do we say, negative infinity to what? Negative 2, and then union 2 to infinity, and it concaves down between negative 2 and 2. Right? Now, do you see that the concavity changes right here? Those might be inflection points, just like when the increasing, decreasing changes, those might be maximums and minimums. So here's what I would probably have written on my paper. I've already filled in the concaving up and the concaving down from the chart, and here's what I do. I write down negative 2 comma something and 2 comma something. Now, don't do it if you got pen, just stop and watch. What do I do to get the y coordinates? Where do I plug into? But what happens on this one when I plug those numbers in? What's going to happen on the bottom? They're going to go to 0, which means this is undefined. So it's undefined, so what does that mean? That means there must not be an inflection point there. Isn't the same thing going to happen if you were to square a negative 2? So my 2 possible candidates, neither one panned out, so that means I must not have any. So if you plug the number in and you get an answer, that's your y coordinate. But when you get a number and plug it in and there's not an answer, that's how you know you don't have one. But the process is the same for this and for this. You take a derivative and you make a split point table and look at whether the final signs are positive or negative. Where's your homework going to be? Middle. Okay. Y'all have a great Easter.